Hello, everyone. This is Vanya here. I am the head of technology for Thoughtworks India. And now I would like and hand over to Pramod to introduce himself, our speaker here. Pramod?
Hello, everyone. And like Vanya said, good morning, good afternoon, or good evening, or good night, wherever you are from. And hopefully you have a drink in your hand, appropriate for the time of the day that you are at. And I'm Pramod. I mostly do data work at Thoughtworks, and I've been here for almost 23 years, starting from the time Martin gave us training about Agile and TDD and this stuff. And then later on, Martin joined Thoughtworks. And I've learned a lot in the 23 years of doing iterative and evolutionary design and implementing processes and practices about different ways of doing building software. So glad to meet you all, and hopefully you can get answers to your questions or learn something new that you can implement later on.
Thank you, Pramod. I think without any further ado, I would just like to start the tone of this webinar, right? And for that, I'd say that CI/CD is not a new thought process, right? In fact, continuous delivery was referred to in the Agile Manifesto back in 2001. And come 2010, we looked at the rise of an aligned but distinct thought process known as the DevOps movement, right? And along came the CI/CD with a lot more vigor, right? And it is during this phase we could see more and more organizations adopting this to radically transform the way they deliver software in the hands of their customers. And for today, while we do a more focused conversation, I want to ask Pramod that why do you think that CI/CD is important in the context of databases?
Thank you, Vani. I mean, we could do CI/CD without the databases. I mean, sure, you can compile the code and deploy it and that kind of stuff. But as you know, most business applications have to deal with data, right? Either like I have a quote sometimes I use, and it kind of makes many people think a lot about what they're doing. All business systems we write are in the service of data, right? Like you write an API, the API is doing like taking some data from somewhere, giving it to someone else. You write a UI, the UI is showing data, or you write some kind of other backend systems, data engineering systems, or whatever it is. It's all in the service of moving data from one place to another or showing data and things like that. Because ultimately in business systems, the data is what is around. Systems come and go, like software systems come and go, but the data is what stays forever. So if your CI system is, or your continuous delivery system is not taking into account the data that it is either trying to read or trying to write to, then I think we have half a system. Like think of like a car with just two wheels, right? It's not really doing the type of, you're not gaining productivity, you are not gaining the efficiency that you are looking for. Neither are you gaining the velocity of deployments, the velocity of feature releases and stuff like that, because half of the system that's supposed to like go with the same flow is not being taken care of. That's why I think like continuous integration to begin with, and later on continuous delivery matter a lot. Like, and within that, the concept of not just code, but even the data and the databases that follow that is critical, because whenever you deploy code and it's going to talk to a database, the database better be at the same version that the code expects it to be, and you better not lose any data in the process. So those two things combined together, I think make putting databases under CI and CD very important. And at the same time, you also want to ensure that the silos of development and the silos of data people kind of come together and provide the lift the organization is looking for.
Absolutely, that definitely makes sense, Pramod. And with that, I guess I can think of a lot of scenarios which are going to be bubbling in our audience's mind. And the first important one that I can think of is that what sort of advice would you have, for our listeners on salvaging a database which is existing, right? And it has no version control at all, and it is pretty much managed in a very traditional sense of having a DBA, managing the updates or changes that are required pretty much outside the scope of the application development that's happening. What do you think, in that in such a scenario, could be a starting point and a way forward?
Yeah, sure. I mean, like many a times it does happen, right? Uh, like to be honest, even my first project, right? My first project at Thoughtworks, we were not doing agile. This was 1999, and we had a big database. It was not under version control, and I was the DBA managing that database. And people came, like all the developers, basically came in and said, "I want to change this, I want to change that," and things like that. And then I would basically make the change and keep a list of changes that happen so that we can deploy them later on to QA and things like that. But at some point I realized this is one, first of all, too much work for me, right? I have to keep track of all of this stuff. And the second part around this is the whole notion of having the ability to know what to be deployed when, right? So for example, if I deploy build number 52 in whatever environment, the database should match build number 52, right? So when that happens, you need to ensure that the match of the versions happens. And the second thing was some kind of automation, right? Like, so I am not doing all the work, right? The DBA group is not doing work. Many a times it happens like in a traditional setup like this, where the database is managed by a DBA group. Then you send a request to the DBA group. The DBA group may be busy because there are like 10, 20, 100 developers sending them requests. You are in a queue, then you're waiting, right? And that waiting period is very difficult for developers because they want a change done so they can move on to coding and all the other stuff. So that waiting is painful. And the second is if the DBAs have some kind of comment on what you're asking for, then the comment comes back and then you work on it and then you send again and then you go into the queue again. So waiting. This waiting period was very painful because I alone was handling about 20 to 30 developers on the team, right? So I wanted to reduce that wait time. And the other aspect of this was also I have a diagram for that, I think. Let's see. So the other aspect of this was because we are in this, like there's a development database where everybody is using that, all the developers are accessing the same database. And then if I make a change in that, there are 2 or 3 things that happen in this scenario, right? So one is when a DBA makes a change in a schema, the developer has not checked in the code that matches that schema, but everyone by default gets that new schema, right? So imagine as a DBA, I make a change in this developer schema. The pair of Andy and Joe or Jim and Rex or Jack and Ram, they all get the change because once you make a change in the database, everybody gets the change, right? So that's one problem because Jim and Rex and Jack and Ram may not care about the change because they are behind or they have not yet pulled the latest code that Andy and Joe are writing, right? Andy and Joe may not even written the code, talk to the new scheme. So it will break their builds in weird ways that may not be debuggable or may not be like easily known like what's going on. So there's a lot of time wastage in that kind of scenario. And the other aspect is like when Andy and Joe are asking for this change, they know that if they break something, the rest of the team cannot work, right? Or they cannot work productively. So they are going to be very conservative in the type of changes they're going to ask, right? So I believe and many of us will attest to this, is when we make some changes, we are going to iterate over like, oh, does this design work? Does that design work? Like same thing happens even in the code base, right? Like we try out an object design or something, it doesn't work, we change it and that kind of stuff. So that experimentation or iteration on experimentation until you arrive to a good design, right? That is not possible in this scenario, right? So it's better to be in a place where you have your own schema that you can play around with and you can make all the mistakes you want. You're not going to affect anyone else. Then that freedom gives you the ability to experiment and come out with better solutions. And when that happens, right, you liberate a bunch of things. Like a bunch of things happen. Like one is to make the scenario of like the green tick mark here. You have to ensure that your database is not in the database, right? Like it has to be extracted out. So to do that, I would say, if you have an existing database, run some tool, right? Like there are tons of tools. The database vendors themselves give a bunch of tools. Like if you are in Oracle, like the DBMS metadata export stored procedure will basically export out your schema. If you are in SQL Server, the SQL Server Management Studio, you can just say right click and script the database. So it gives you a script. PG dump in Postgres does the same thing. If you are in like MySQL, the SQL Workshop tool does the same thing. Use whatever tool, right? There are also other commercial tools like the Toad or the Embed Corridor, a bunch of tools. You use any one of those tools and extract the schema out, right? And when I say schema, it includes everything like tables, stored procedures, if you have synonyms, sequences, views, indexes, any constraints, if you have comments in the database, anything that is not data, right? And anything that your application needs to run. So extract that out and make a file out of it. Like let's just say one big file out of it, right? And once you have that text file up, like then now maybe you can split it into like tables.sql, sequences.sql, synonyms.sql, whatever, basically split it by object. Now, once you split it by object, you'll realize there's a sequence to this. Like you cannot run the views before you run the tables. You cannot run the sequences. You can probably run the sequences without anything. You cannot create indexes before you create the tables, or you cannot create comments before you create the tables, things like that. So you will have a logical sequence to these things. So once you know those things, you can just create a build target. I don't know, maybe you are using Maven, maybe you're using Gradle, maybe you're using uh, .NET or whatever, like MS Build, for example. Doesn't matter what you're using. Create a build target that can basically run these files in the order that you think is the right for your database, right? So create a new database, and especially the rise of Docker and containers and stuff. Nowadays, getting a database for yourself is pretty easy, right? Like let's say if you're doing Docker Postgres, you can just say Docker pull Postgres, Docker run Postgres, you have a database for yourself, right? So once you have that, basically run this build target that can recreate all of those objects, right? So you will have a schema now. At this point, you will have a schema that should match what is in your development database or production database. Doesn't matter whichever database you pick up as the source, right? So, but that is not enough for your application to run, right? Our goal should be in this stage to run the application on this newly created database without doing a backup and restore from any one of database. That's the goal, right? So we have a build target that creates all this structure in the database. Now we need to work on getting like the reference data or any kind of data. Like there are many applications where there are no UI screens to put reference data, right? Like a list of table, a list of addresses or address type, or list of states, a list of customer types. There are like all these small reference tables with 4 or 5 rows, sometimes 100 rows, that are all reference, and they usually we don't have a screen to put that in. There may be configuration, there may be like other related reference data or even configuration data. So you have to first go analyze what all of that is, right? And once you know what that is, again, you can like script the data out and put them in SQL file. Like that's the bare minimum, like put them in SQL file so that you can run them, right? Like run it again using a build target. So the first build target creates a structure. The second build target gives you like the bare minimum data that you want for the application to start. So at this point of time, any developer should be able to like do the Docker pull and Docker thing, set up a database. The next step should be for them to like create this structure and stuff like that. And the third step is put all this reference data and things like that, and run the application and see what you do. See what the application does. And hopefully you have some automated tests that you can run on top of this application now. And it will tell you like, okay, I'm missing this, that. So there is a small iterative cycle going on here, is trying to figure out what kind of state your database built from scripts is at. And iteration over this, you'll get to a point where the application is running fine and you have your all the structured data in the scripts in there, as well as you have all the data necessary for the application to run that needs to go in production. There's one other type of data that you need, which is test data, right? Like something that the users can see. developers don't really like to create good data. They'll say like, oh, the customer is named Foo. You'll see this all the time. The customer is named Foo, or the location is named as bar or something, right? So create some scripts that will give some test data into this. This doesn't have to go to production or doesn't have to migrate through any other environments, but a sample data set for the developers to play around with, right? So we have text files or code files in SQL that create all the structure, that give you all the reference data, configuration data, as well as some test data, right? Now, these files can now be checked in along with the build script you wrote and along with the Docker scripts you wrote, can all be put into your version control repository, all right? Now, any other developer can now check out that and basically run the same exact step and have an environment for themselves. So now if Andy and Joe did the same stuff, Jim and Rex or Jack and Ram, can they all do the same thing? Now in this particular diagram, I'm showing you have a big database and everybody has their own space within their, like their own schema within their own database. This might as well be running on your own laptop or desktop where you don't need to basically connect over the network to a centralized database, right? Because the structure and the reference data is all in version control now. So if someone wants to change something, they'll have to go to the version control and not to the database. So now the DBA has basically extracted themselves out of this process of making the change in the database. Some people have this question of, does this make that the developers can do whatever they want? And the second question is also, does this ensure or does this make that you have like hundreds and thousands of database copies that are not in sync and that kind of stuff? So again, so the first step we have is a database script that can recreate the structure, get your reference data, put it in version control, right? Once we have that, the next step we have to go to is the ability for developers or the ability for the business or the ability for DBAs to introduce change to this database, right? Because we can't work with a static database. That would be totally counterintuitive, right? So once, like there's multiple ways to do that, right? Like there's a migration based approach and there's a backpack based approach that is more popular in the .NET world. Both approaches are equally good. Both approaches have equally pros and cons. So you, based on what kind of setup you are in, you can pick one of those approaches, right? So let's talk about the migration approach so that we are not talking about many approaches here. So in the migration approach, what we are saying is the database that I extracted out from the current development or current production environment is my baseline. Like that's the current state. And any new change that I'm going to introduce is basically a migration on top of that baseline database. So think of like state migration, right? You're in state 1, you're going to go to state 2, state 3, state 4, state 5, so on forever, right? And state 1 is basically a new change that you're going to introduce, right? So here's an example of like a state change that we do, right? So like here, for example, we are introducing a discount type table. So the primary key, the description, the reference or whatever. We also have some reference data that discount types can be of amount or percentage, or discount can be on the total price. This is all the change that the developers want to do, right? So this does like multiple things that are good for you. One is every change now is auditable, right? Like every time, like, why did I make this change? What was the business need that made the change? Who is the person that made the actual change? When was it made? All of these questions can be answered now because this is being created by a person. This is being checked into version control. The version control remarks or description should usually have a story card number or a Jira card number or whatever that is. So that will give you a link to the requirement that came. The requirement, the Jira card story or any other story will have what business need was there. So it gives you a lot of auditability benefits along this side. The other thing is also it helps you in is because the DBA is now not making changes in the database and is a queue for many people, that person is now free to basically compare with the developer while making the change, right? So the benefit of that is so that we can get review, peer review, right? Like the DBA is sitting or in this remote land, probably is on a Zoom call with you and trying to like work this script with you, right? So the review happens much before. One of the underlying tenets of continuous integration is feedback, right? Like the faster the feedback, the better for you. And this way of like bringing the database person much before the cycle and giving them an ability to look at what you want to do and pair with you and come up with the right script is again feedback, like feedback given by the DBA to the developer. And this helps the DBA to keep tight control on like the design specs, the naming convention, and all the other things. And also it helps the developer to understand what kind of like production metrics are there. Like maybe you will do some table design that may not work with like millions of rows in production, right? So that kind of feedback you get from the DBA, and that helps you become a better developer, right? So two-way communication helps both sides of the shop. And the other thing this also does is, because every change is contained, now the business can decide when to deploy, right? So that's again one another smaller step to go towards continuous delivery, right? So because every change is coded like this, you can basically decide like tomorrow we are going to go to production. You basically take whatever changes until today and you deploy, and tomorrow you're in production. You don't have to think, what do I need to come up with as a migration script to go from change version 1 to version 2, for example, right? That's all, that was already done during development time. So I have like a diagram to kind of like talk about that, right? So I talked about like the migration script. The developer and the DBA are basically working through that and trying to make the change. You can use Rake, you can use Gradle, Maven, MS Build, or maybe on Ant, doesn't really matter. They are working on their own database, making the change, iterating on that cycle. And once they are comfortable with the change they make, they basically push it to source control, and your CI server basically takes those changes. Remember, we have a baseline, and this change is on top of the baseline. So the CI server basically pulls down that migration script you wrote and then basically applies it to its own database. It's not the same database, its own database. And then when all the build passes, hopefully you have tests like exercising the database change and things like that. And then you can publish an artifact. In this artifact publication, you should include all the database related changes also, right? Because you shouldn't have to come back to the version control or to the database to figure out what changed. It should all be self-contained within that package. And then you can just deploy that package wherever, like it could be to your QA environment, it could be to your UAT environment, and similar change to apply to like prod environment. You may have 10 different QA environments. All of the same thing applies to this. And each of those QA environments even can be at a different release phase, like build 300, build 310, build 500, doesn't really matter, because all the changes are coded inside the package that you built or the artifact that you built. So that gets you to the basics of like out from a place where you are doing a DBA managed change control to a version controlled migration driven change management of your database, right? So of course you're going to learn a bunch of things during this cycle, right? Like how do I name the changes? What tool do I use for migration management? For example, Flyway is the most popular one right now. There's also DACPack is the one that my MS Build has, or in the Microsoft.NET land. We also have like DB Deploy. We also have iBatis, Liquibase. There's a bunch of commercial tools also available depending on like what kind of flavor you like. You can pick whatever you want. So multiple options are there. So you have to like go through like a good trade-off analysis of what do I do here, and then basically implement that tool, and then you'll get to a place where you can like my goal of this is when a new developer joins a team, they can basically like check out the code base, and then there's a bunch of instructions for them, like here, do this Docker stuff, next is do this, and that will get your database up and running. Next is build this, you can run your application against this database and you're set, right? So at that point, I think you're in a good state. I think I gave a long-winded answer one.
No worries at all, Pramod. I think that was quite informational. But there are a couple of questions that are aligned to what we just discussed from Barney, and he or she, I'm not sure, is asking about whether the baseline should happen first from the version control, or what should be the order, so that it doesn't get out of order for the changes that the developers are trying to make. And I would imagine that as a starting point, the the baseline migration script is much more important, so that we can version control from there and start adding any migrations iteratively on top of that. Would you want to just comment on that as well, Pramod?
Yes, certainly. I mean, baseline is the first because it will give you a good place to have a database and an application running, right? So you know that your production is running, for example, fine, you don't have any issues. Then you can take the production as a baseline and then like extract it out, do all this stuff and make sure the application runs fine against that. Now you have a known baseline. Now, of course, a bunch of changes may have happened in development since the time you started doing the baseline stuff. So you have to find what the delta is and make that your first migration, for example, right? And then now you have whatever the current state of development as version 1 on top of that baseline. And that helps you, one is learn this basics of like how this takes some learning also, right? Like some self-control, like developers will want to like, I made the change in the database. Now, why are you asking me to make a change here and things? So there is a little bit of difficult phase of learning this. But once you learn, developers will be happy because the change is under their control. They don't mess up other developers and things like that. And the DBA is happy because it gives them very fine-grained control on what is changed, when it is changed and things like that. They can literally see every change. They can influence every change. They can code every change and things like that.
Right, right. So Barney just confirmed he's a he. So there's another question that Barney is trying to ask, which is, would the build artifact, which is published at the end of the pipeline, contain just the new migration scripts or the entire history of the migration scripts? I think that's a great question, Pramod. Would you want
Yes,
to
certainly. And I would package everything from like version 1 to version, whatever current version, right? So let's say we have 200 changes, right? Like since we did the baseline, we have 200 changes. I'll package all 200. And the reason for that is you don't know the version of the target, right? So that's a difficult concept to understand. So let me like elaborate on that a little bit. Let's say the production is at version 178, right? And you are going up to version 200, like the changes, right? So if you had like packaged everything, then you would just say, apply this change. And so the tools I talked about, like Liquibase, Flyway, or DB Deploy, or whatever, they maintain metadata in the database that tells them what version was last applied. So if the last applied was 178, the Flyway, let's just take the example of Flyway. Flyway will look at that and say, oh, I need to apply everything from 179 to 200 or whatever is the latest. Like 200, I'm just saying because that's the number we have, but whatever is the latest. So it basically picks up all the scripts, combines them and runs them, and that's it, you're done, right? But let's say, for example, you have a bug raised in production that talked as of version 156, right? Like 156, someone had a bug that told you something. And now the developer is trying to work on this particular bug, and the developer says, oh, I need to get a database as of version 156, right? How would they go to that, right? So you take the baseline and everything from version 1 to 156 gets applied, and you get a database as of 156, right? So keeping this discrete and keeping them packaged all the time helps you to go from any version to any version, right? And that flexibility, I think, really helps you. We'll talk, I think, in situations where you are like shipping software to customers and things like that, this really is useful. If you always say, oh, I know exactly what version all my environments are at, then maybe you can like package less of that. But ideally, it's much just easier to package everything. Of course, there's a supporting question that comes when I say this is, what if I have thousands of changes, right? Do I package thousands of changes? You can make a very good case for rebaselining at that point of time, right? So you say, okay, I have thousands of changes now. This is getting too difficult. Let me rebaseline. And you can say, oh, I know for a fact that nothing after 2052 has been is going to be needed or is going to be needed before that, right? So you can baseline all the way up to 2052, and that becomes your new baseline. and 2053, 2054 are still there. You don't need to change the numbers or anything like that. Those can still be there, but you have just compressed all the changes together. That's a little bit advanced topic for some people to understand, but if you run into that problem, like thousands of changes, like ping me on Twitter and I can definitely help.
Right, right. I think, Pramod, you were trying to hint towards the reproducibility aspect when we said that we need to package all the migrations up to the versions that we have seen, so that we can
Right.
use any specific version at any given point of time. I think that's a great way to summarize that. But there is another interesting question from Aaron. I think I'm going to take one more on this topic so that we can move to the other, which is around how do you think about managing scripts that only need to be run once, right? And how do you make sure that you deploy them across your different environments, like your dev, staging, and say the production one?
Yes, certainly. Like if you need to be run it once, right? Most of these tools, like even Flyway or even this, they have like a pre-process step or a post-process step or run only once. So there are multiple stages within that cycle, right? Like the general cycle is I run the script, like for example, the create a discount type table that I showed. If you run that once in the database, you cannot run that again because you will get an error, like the discount table already exists, right? So the tools basically manage what was run and what should not be run again, for example, right? The flip side of that question is I want some scripts to be run always. Like every time I run any kind of migration, I want this script to run. And an example for that is like recompile all the views, for example, right? Or recompile all the stored procedures. Some people may want to like regenerate the statistics in the database, like recompile all the statistics for the ease of query plans and that kind of stuff for the optimizer. So those are things that run every time. So you can have a post-processing step that says, oh, analyze all the tables again, for example. And no matter what change you run, that step runs all the time. So there are different stages that you can use this for.
Absolutely. I think there is one interesting question as well, which should be answered before we move forward. Pramod, is running the database integration build against a disposable container a good approach? I think any thoughts and pitfalls against this?
I mean, it is a good approach, right? Like you want the database to be in a state that is pristine before it starts running, right? Many a times, like before even containers and things became vogue, I used to basically run a script that dropped the schema and recreated the schema and then ran the whole thing again. So I am in a pristine state always. So there is no corruptible information in there. Neither is there like somebody introduced a change in the database directly, right? That made the build pass and things like that. So you can just like get rid of that. And nowadays containers make that super easy. Like you can just like dispose of the old container and rebuild the new container. That's a great way to like ensure that only the things that are in the version control are run against the database, right? So this kind of setup also forces you to get into that stage where if you want something to be deployed to the database, it better be in version control.
Right, makes sense. There's another question, but I can type the answer for that, which is around the DB migration tools. Pramod, you mentioned Liquibase, Flyway, any other specific ones that you have had good experience with?
Yeah, Liquibase, Flyway is there. I and Nick Ashley actually, and a bunch of other thought workers from London open sourced DB deploy a long time back. But that framework is kind of old now, and not many people. There's no active development on that. Sure. But there's also like iBatis Migrator, there's DB Maintain. There's a list of these tools on my DevOps for DBA website, so you can just go look at that.
Fantastic, fantastic. I think now, Pramod, we should sort of change our gears and look at some other aspects of database refactoring or database versioning. And with that comes a very interesting question on if we think about a service-oriented architecture world, right, where we have a same single database instance, but we have different teams componentized across the business boundaries, right? They are connecting to the same database. And in such a place, how do we think about managing our database versions when we have different teams working across different domain boundaries, but are still trying to connect to the same database instance? Any thoughts about that?
Yeah, certainly. I mean, that's a very common situation, right? Especially in a big monolith that has been very well designed. Even like in places where you have a much bigger code base, so you need more than one team to like do that kind of functionality. It is important that we basically ensure that the basic tenant of CI, which is feedback, is given, right? So I think I have a diagram for that. So let's see if I can get this thing going. So here, right? So this is what we are talking about, right? So there is there are modules, or maybe there is code base. It could all be one single code base with different packages for different things. Or it could even be like a mono repo with separate folders for different packages and things like that. But the ultimate situation we are in is there are multiple packages or multiple domains that are talking to the same database. And I think Gregor in his enterprise integration patterns book described this concept as like database-based integration, right? Like customer management puts something, creates something, and the order management is looking up customer in the database. It's not calling the customer management, right, module. Similarly, like order management may put something in the order, and the payment processing and the item management basically are looking in the database. So the state of the database and the structure of the database is the coupling point where all of these things come together, right? So what happens in this scenario is, like, let's say the order management goes ahead and changes something, right? Like let's say they change the item table, or they change the way the inventories table is structured, or things like that. So in that case, the item management module basically breaks because they change the table name or column name, or they split a table, or they did a bunch of different things like that, right? So this is database-based dependency that is happening. And the tricky thing with database dependency is it's a runtime dependency. Like someone changes, like in the code base, for example, if you change a method name, the code doesn't compile, or the code just stops working in Ruby or non-compiled languages. You basically hit that point and it doesn't work. But in database, if something changes, until you hit that point, you don't know what changed, right? So that's what I call a runtime dependency. And unless you have good ways of like testing it beforehand, you cannot spot these differences, right? So dealing with this kind of setup, it's important that first of all, you should we should like treat your database as if it was an API. Like you don't know the consumers of this database, and any change you make here is going to break someone, right? Like doesn't matter what kind of change you make, it's going to break someone. So in that scenario, first of all, what you should do is probably extract out the database as a separate code base or as a separate folder or something, where when some change happens within that folder or within that project, you are automatically triggering a build for all of those components, right? So for example, if someone changes stuff inside the order management and that involved a database change, the moment that build runs, it should trigger like customer management, payment processing, item management, or any other builds you may have. There's a reason why I have some in teal color here and some in black. And the reason is you may not have these other 4 things in the black at the bottom under your control. Like you may not even know how stuff runs, right? So you also need to communicate with them, like something changed like this, that you ensure they also are up to speed and things like that, right? So the teal or customer management, order management, payment processing, these are all under your control or your bigger program control, but the black ones are not, right? So you need to first of all communicate there. And in the teal, you also need to ensure, like if the order management team checks in something and it breaks the item management, you need to ensure that you either you go fix that if you have like common code ownership. If not, basically go talk to that team and tell them what you did and that kind of stuff, work with them to get it fixed and then move forward, right? So some kind of dependency management becomes really important. So one other thing you could do at this point of time is introduce like a concept known as behavior driven development. Like Dan North introduced this concept back in, I think, 2006 or something, where you are considering whatever the thing you are testing as a box, right? And you don't know what's going on inside, and you're testing from outside. And the outside tests are basically ensuring expectations are met, right? So I'll take a simple example of this scenario. let's say you have, we looked at the discount table, right? So the discount table had a primary key, a description, and what kind of like a string that is expected, right? So from the outside, you can say, oh, I'm expecting this table to have these 3 columns where the primary key is not null, the description is not null, and the reference string is also not null. So your code can just try to like insert some null values and you'll get an exception, right? So that's expectation. You're expecting the table to give you some kind of like API, some kind of expectations that it will meet. And if someone later goes and changes those, like let's say someone introduces a new column into that discount type, your test should basically fail and tell you that, okay, I'm dependent on this table. And if someone introduces a change that breaks this table, that's a point of a conversation. Like, okay, let's have a conversation of why you put that test in place, why you made that change. Let's like get on sync and either change the test or change the table or whatever that is, right? So it's an early warning system that you can embed in an automated way that will tell you what's going on, right? So these kinds of database integration tests become really critical in this kind of setup.
Right, right. In the interest of time, Pramod, I'm going to head off to the next segment of our conversation, but there are some interesting questions which I'll try to get back to, in the course of due time.
Sure.
I think we have spoken about how important is those segregations and those communication when we are talking about a modular monolith sort of a scenario. But if we just change gears and talk about in this digital age, right, when we need to create better customer experiences and provide better products, in an iterative way and we are expecting our applications to evolve at a much faster pace. So how do we sort of, think about managing growing application versions with the same database instance, right? Like I can think of alpha beta testing, but the database instance that's supporting those tests are still the same, right? Any thoughts
Yes.
about that?
Yeah, certainly. And a very like elegant way to think about that is your schema is basically an API to your data, right? If you think of it that way, then you can think of like multiple versions of schema that can give you the same data, right? A very good example of this is, let's say I basically like as the product evolved, I am now calling my customers, not customers, but parties, because even organizations can be customers and things like that. So I introduced the table called party. But the older versions are in the A/B testing, the B side, for example, is still using the customer table. I can just create a synonym that is called as customer that is pointing, it's like a symlink in the database, right? That is pointing to the party table, and the older version can just keep going. Like the example would be something like this, right? So you have multiple releases talking to the same database, and you can have the database support different versions. Like there are concepts in the database that you can use, like synonyms, views, triggers, as well as the concept of like virtual columns, right? So all of these can be combined together in an intelligent way so that you can give a facade to the end user, in this case, your older versions of the application, that can they still think of this database as the same version that they were talking to, but underneath the data and the schema is migrated onto a different version. Right? So I call that a concept of like expand and contract, right? In the beginning, you're basically creating scaffolding around your tables and things like that. So that, like, for example, you introduce views to transform the way the column names are called or whatever. You add some virtual columns, you add some functional columns, you add some triggers to move data around. And when everything, like all the other versions, move up to version 2, for example, then you can like basically remove all the scaffolding away, and then you will get to a state where they're actually talking to the real schema and things like that. So you are basically giving a facade on top of the current schema.
Right, right. Pramod, there is a very interesting question that has come up from Peter. It's not directly related to this topic, but definitely worth asking, which is, if we run a third party or a proprietary software that allows for custom code to be integrated with it, should the custom code and custom schema changes, which I'm hoping the application development team is writing, should it be version controlled separately from the proprietary schema objects, or should it be all version controlled collectively? Any thoughts?
Yeah, so great. I think that's a great question. There are 2 or 3 things here come. Like one is the notion of coupling, right? Like just pure architecture wise, if you're all into their code base and if you're tightly coupled, when they change their version, how does it affect you, right? So like from our software architecture point, you need to think like how tightly or how loosely you want to be coupled. And the other thing you need to think about is if you keep it separate from their code base, can you run their database creation script and then your database creation script and have a combined test that runs and then tells you what's broken, what's not? That's a good state to be in. If you are all merged in and they upgrade their version, then at that point of time, what is your change and what is their change? It's hard to figure out, right? So if you think of the proprietary third-party system as if it was like a library, you want to keep your code base and your database structure away from it, right? Even the tables should be designed in such a way that you're not adding columns to their tables, or you're not adding lines of code to their stored procedures and things like that. So if it's a loosely coupled system, you can like literally bolt on to their newer version and then find what breaks and just fix that, and then you will be in a better state. If you're totally coupled in, I think it will be really hard to figure out what changed on their side and why it broke. And at some point of time, it will be even really hard to figure out what is mine and what is theirs.
Right, right. Pramod, there is one more interesting question. It's sort of related to the previous concepts that we discussed around database integration tests. But if for some reasons the changes or the migration has broken the system and the integration has failed, what would be like a recovery from here? I mean, any outliers for how do we think about this? Is it going to be manual, or should we write another migration to fix that problem?
Right. So the question is, where does it break, right? Like if it breaks in the CI environment, you can always change the migration script, and your CI environment can be basically like, again, go Docker, like create a new instance of your database and off you go, and then you can fix it that way. If it breaks in the like any environment beyond like QA or UAT, or let's say in production, then there are multiple ways to deal with that, right? So one way to deal with that is how it broke, what it broke, right? So in multiple scenarios, like people have downgrade scripts that are written along with the upgrade script. So you can downgrade the database and then take your time to fix it and then upgrade it back and things like that. There are some places that say, or there are some techniques which say you're always going to go forward. So if something broke, I'm going to introduce one more change that will do like override or fix that change and keep going, right? There is one other scenario where people say, okay, something broke, and what is the kind of breakage, right? Like, is it just data that is broken, or is it the structure that's broken? Based on what is broken, you can introduce different kinds of changes within that. Liquibase especially introduces this concept of like sub changes, right? Like I have introduced 1.0 and I've introduced 2. Now something broke in the middle, so I can introduce 1.1, 1.2, 1.3. So Liquibase allows that concept of like sub changes and things like that. I think there's one other tool called DB Maestro that does the same kind of concept of like sub changes within that. So those are like minor release. They call them minor releases. So you can pick one of them. Again, one of the side effects of this is now that this thing is under control, you can literally release on a daily basis, right? So batching the release and releasing once in like 2 months, 3 months is not necessary anymore, right? Like if your stories, if your features are like well scoped, small enough, you can literally release on a daily basis. Some companies that deploy frequently also introduce database changes much ahead of feature releases, right? So you can introduce the database change like say 2 weeks before the feature flag that uses the table is turned on, right? So that's another concept that people use. So in that 2-week period, you know, okay, should I use this? Is this broken? So you have time to like fix that.
Right. I think, Pramod, you have already touched upon certain workflows that can be established here for streamlining the way the database is changing and the evolution of the application code around it. But there are 2 interesting questions, one from Barney and one from Abhimanyu, which are sort of related to the team and organization aspects, right? The first one is around if the size of the company is small, right? And people don't mind waiting for the changes to happen to the schema. would there still be recommendation, for having these version control databases introduced into the organization? Any thoughts about that?
Oh, there's certainly, like, the smaller your team, the more you want to liberate your DBA, because you don't have an army of DBAs, right? And that person is more valuable in like sitting with you and designing the change, sitting with you and designing the database structure, the data model, and things like that, instead of like waiting at the end of a queue and basically taking your change and writing that change in the database, right? That person is more valuable upfront, especially like in a small team or a startup kind of environment, right? And the other, I think, what was the other question? I forgot, sorry.
Sorry, Pramod, there is a slight tweak to this, that there is no DBA in the picture, right? The developers are making their changes themselves, but still there is no version controlling that we are doing. Any motivations to still move towards a version control approach that we are
Oh,
doing?
yes. Yeah. Certainly. Thank you. So yeah, certainly, like let's say there are 6 developers making their own changes in the databases, right? Directly in the database, no need to version control anything. You still want to do version control of these things, because that will tell you what changed when you deploy to the next version, right? Like next environment, like you go from dev to QA, then you have to figure out, okay, what changed since the last time I deployed. Then you will have to do a diff or something, and the diff only tells you the structural diff. Then you have to figure out what was the data diff, and then all of that is new, kind of like new changes, new development, and nobody tested that. Like it didn't go through the CI cycle or anything. You're just deploying it to QA, hoping it works, right? So if you go through this cycle of like everything gets tested in CI, you have the confidence that this was tested. This was tested multiple times in the CI environment. This was tested multiple times on all developers' environment. So you have the confidence that this change is a good change to be deployed to the future releases or future environments or further environments. That's one change. That one thing that you need to be like as advantage of this thing. And the other is the rate of change, right? Like one developer says, oh, I want to make this blah, blah, blah. And like say, let's by mistake drops the party table, right? Or drops the customer table or whatever that is in the dev environment, right? Now, everybody who is running their tests that is dependent on the customer table, all their tests are failing now. So the productivity of the team goes down. And in a small team, and when there are no other people around, the productivity is king, right? You need to protect that. You need to make sure productivity stays high. So there's one other reason to do that.
Absolutely. That makes sense. So the aligned question that I wanted to ask on behalf of Abhimanyu is of a case where there is a separate team that's managing the database. For instance, in a client and a vendor scenario, the clients are managing their databases themselves and the vendors are building services against them, right? And Abhimanyu says that they have built a facade layer which lets them iterate faster without being dependent. But every now and then when the baseline changes, they have to patch, right? And if there are any recommendations here in this case to optimize this workflow?
Yeah, at that point, I think you need to get into a state where you have good tests, right? And good tests for like the BDD style test from outside in that exercise the facade. And when stuff changes, you can like, the patching is basically the next release, right? Next release of the version or next release of whatever. And it's just new release of something. And when you have that going on, you can just rerun the test and ensure that what I was expecting is being met, and then you can iterate faster on that. Right. Better testing, I think, gives you faster feedback, and that helps you release things faster.
Right. And I think in the interest of time, I'm going to move over to the last segment of our conversation with Pramod here and start talking about client installed applications, right? Or where we are shipping software either as a SaaS version or something that's going to run as an executable or a binary on a system that client owns, right? Like more from a WordPress sort of a scenario, right? And how do we think about managing the database versions across the versions of the application, right? Where specifically where we have certain bugs that come up in the previous versions, and it's hard to sort of have handle on what clients are using what versions. In this case, Pramod, what is your approach to help with the database versions?
Yeah, certainly. I mean, WordPress is a classic example of this, but there are many, like say, for example, Oracle financial applications, or you may be writing office like dental office management software, or a bunch of things like that, right? Like every customer is at a different release. This could also be true for SaaS software. Like you are a SaaS company and then you have like stacks of software for different customers. Like every customer has their own stack, either for data privacy or data should not be mixed with other customers and things like that. So in that scenario, like I think that's a good example or a diagram I can share about these things. So like, let's say you have customer A that's at release 1.5, they're using their own database. Customer B is release 1.8 and customer C is release 2.1, right? In this kind of scenario, how do you ensure that you don't get the burden of knowing, oh, I'm deploying to customer A, they are at release 1.5, what kind of migration script I should give them, right? You don't want to be in that situation, because if you have thousands of these, then it's a nightmare. And all the kinds of like testing and mistakes that can happen is really too much work, right? So the best thing, I think we talked early in the conversation, is when you package the artifacts, make sure you package everything, right? And when you run the upgrade looks at the database and says, oh, this is at 1.5, I'm going to upgrade from 1.5, because you have all the deltas within the package, right? So the customer most probably is downloading the package from your website, or probably you ship them or something. And then they say, okay, I'm going to deploy this. The first step of the deployment is you should be calling your own data migration framework inside the upgrade or inside the installation and say, okay, here's a database, run this thing to whatever the current release that this artifact was shipped for. And it goes from whatever release you are at to whatever release the artifact is at, right? So it could be going from 1.5 to 1.9. It could be going from 1.8 to 2.1. It could be going from 2.1 to 2.12. Doesn't really matter, because it all depends on what artifact they downloaded, and whatever artifact they downloaded, it has the capability to migrate you from whatever version to the version of the artifact, right? So that eases a lot of pain for the development team. Again, improves productivity, improves support, and improves the capability to handle thousands of customers. Like if you have only 2 customers, then maybe you don't really care about this system. But if you have anything more than 2, probably you care about this.
Right. I think we have hit the end of time, Pramod, and we do not have any more time to take up any questions, but I'm hoping that our audience could really benefit from this conversation with you on the variety of scenarios that we have discussed around database versioning and refactoring. And I would like to thank you, Pramod, for sparing this time to share this knowledge with all of us. And if there are any further questions that our audience might have, please feel free to reach out to Pramod on his Twitter or LinkedIn. And we can share that, Shani and Kathleen, we can share that maybe in the chat, and people can really get in touch on email, and we are happy to answer all those questions offline as well. And with that, I think we can close our conversation. And thank you so much for tuning in, and stay tuned for the next version of our webinar. Thank you, everyone. Bye.
Thank you.
Have a good day.